We are continuing with the rules of differentiation for topic 2, and we are continuing with the difference rule where we left off. Now, with the difference rule, you have to differentiate the difference of two functions. So, in order to do that, differentiate each function separately and then subtract. So, if you have y is a function of x and it's given by the function g of x minus h of x, then in order to get the derivative, differentiate each function separately and then subtract. So here we have an example. F of x is equal to 6x squared minus 4x minus 5. So the first order derivative is going to be equal to 12x, and I obtain the 12x by bringing the power down, multiplying it by the coefficient 6. So 2 times 6 is 12, multiplied by the variable x, and x is raised to the power of 2. We have to say n minus 1, so 2 minus 1, and that's just 1, so that gives us 12x. Minus 4, how did we obtain that? Well, we have 1 as the exponent of the variable x. We bring that down to multiply it by the coefficient 4. So now we have 4 times x raised to the power of 1 minus 1, which is just 0. And anything to the power of 0 is just 1. So that is just 4 times 1, which is minus 4. And of course, if you differentiate a constant, it differentiates to 0. So please tackle the next example. Here we have f of x is equal to 2x to the power of 4 plus 4x cubed minus 12x squared. So applying your sum and difference rules, you know that you need to differentiate each one on its own and then add or subtract. So that is your difference rule. Next, we will move on to the more advanced rules of differentiation. So you have encountered the previous rules already in ECO 151. None of what we've done thus far should be new work to you. However, the advanced rules, namely the product, quotient, and chain rule, that is new work. So the first new rule is the product rule, and you can refer to section 5.1 of your textbook for additional examples. So first we have the product rule, and the product rule tells you how to differentiate the product of two functions, right? So if a function of x is a product of two distinct independent functions, so here we can see we have two distinct independent functions of x multiplied together, then the first order derivative can be derived as follows. So how does this read? How would we get the first order derivative of two distinct independent functions that are multiplied together? We can multiply each function by the derivative of the other function and then add. And that is exactly what we see here. So we have f dash of x is equal to g of x, which is that function over there, multiplied by the derivative of the other function, which was h of x, plus here we have h of x, which is that distinct independent function over there, multiplied by the derivative of the other function, and then we add. So here's an example. F of x is equal to 4x to the power of 5, and that is one distinct function, multiplied by, here's your g of x, 3x minus 2. So I'm going to write this as my g of x, and I can write this as my h of x. Those are the two distinct functions. Now, if I'm going to get the first order derivative of g of x, I get g dash of x, and that is going to be 5 times 4 is going to give me 20, x raised to the power of 5 minus 1, and that's 4. So g dash of x is 20 x to the power of 4. And h of x over there, if I get the first order derivative of that, I have h dash of x, and it's simply equal to 3 because my power here is 1. 1 times 3 is 3. 3 multiplied by x raised to the power of 0 is just 1, so that is just 3 because you differentiate that constant and it is equal to 0. So I have g of x, I have h of x, I have g dash of x and h dash of x. And what does the rule say? Multiply each function by the derivative of the other function and then add, right? So f dash of x is going to be g of x, which we have there, multiplied by the first derivative of h of x, which we saw it was 3. H of x was 3 plus h of x, that is the other distinct function, multiplied by g dash of x. So we've taken each function and multiplied it by the derivative of the other, and we're going to add them together. So now you can multiply out. That is going to be 4 multiplied by 3, that is 12, x to the power 5. Bear that in mind. We haven't shown each step here. And over here, we have 3x multiplied by 20x to the power 4. So 3 times 20 is 60. And here, when we multiply the bases, we just add the exponents. So 1 plus 4 is 5. So I've got 60 x to the power of 5. And here I'm going to have minus 2 times 20. That's minus 40x to the power of 4. So there's the minus 40x to the power of 4. But remember, I also had 60x to the power of 5 and 12x to the power of 5, which would give me 72x to the power of 5. So I just skipped a step in terms of the expansion and the solving, simplifying thereof. So just bear that in mind, but this is your final answer. Let's look at one more example. Here we have f of x is equal to minus 6x to the power of 5 plus 4. So this is your g of x, and that is your h of x over there. So the product of those two, the rule states I need to have these two functions and the first order derivatives of them respectively. So I have g of x and I have h of x. And here I've got g dash of x, which is the first order derivative of that. 5 times minus 6 is minus 30, x to the power of 4, and that constant differentiates to 0. And the first order derivative of this is 3 times 2 is 6x squared, and that constant differentiates to 0. So therefore, f dash of x is going to be g of x, which is that, multiplied by h dash of x, which was 6x squared, plus h of x multiplied by g dash of x. So now you can multiply out and then you can simplify by adding your like terms, and that is your final answer. So please do this question as homework and we can revert back to the chat room to discuss our answers. The next rule of differentiation is the quotient rule. Now, the quotient rule tells you how to differentiate the quotient of two functions. If a function of x is equal to one function of x divided by another function of x, here we have g of x divided by another function of x, h of x, and these two are independent of each other, then the first order derivative, that is f dash of x, can be derived as follows. So we have the bottom, which was h of x, times the derivative of the top minus the top multiplied by the derivative of the bottom, which was h of x. And all of this is over the bottom squared. So that is your quotient rule. So here we have f of x is equal to 6x cubed all over 2x plus 5. So that is your g of x and that is your h of x. G of x, g dash of x is the first order derivative of that. So 3 times 6 is 18 and 3 minus 1 is 2. So that's 18x squared. And that's your denominator. It is your h of x. So h dash of x, the first order derivative of that, is simply going to be 1 multiplied by 2 is 2x. Well, 2x, just 2, because the x is raised to the power of 0, which is 1, and the constant differentiates to 0. So we have g dash of x, we have h of x, and we have h dash of x. So you will not be given these formulas, you are expected to know them. So hence, the quotient rule says I have to take h of x, which is 2x plus 5 over there, multiplied by g dash of x, and g dash of x was 18x squared, minus g of x, and g of x was 6x cubed, multiplied by h dash of x, and h dash of x we got was 2. So all of this over the denominator squared, or h of x squared. So squaring, where's h of x? Squaring that term. And then, of course, again, you can do your expansion and your simplification, and you'll get your final answer. I will not be explaining that basic step. What I want you to understand is the process of how you need to determine your h of x, your g dash of x, your minus g of x times h dash of x over all over the denominator squared, and then substitute those components before you can expand and simplify your answer. We have one more example regarding your quotient rule. So here we have f of x is equal to 22 x to the power of 4 minus 15 over 8x minus 1. So that is your g of x, and your denominator is your h of x. So we need to get our g dash of x, which is going to be the first order derivative of that. So 4 times 22 is 88x cubed, and that differentiates to 0. And we also need to get our h dash of x. So these are h of x. H dash of x is equal to 8, simply 8. So now you can go ahead and substitute. Remember, you have your h of x times your g dash of x minus g of x times h dash of x over h of x squared, right? Your denominator squared. Then you can multiply out, and of course, you can simplify your answer, right? This final question, please do that as homework. And again, we will check our answers in eCanva in the chat room. The final rule of differentiation is the chain rule. Now, the chain rule states that if y is a function of u, and u is a function of x, then dy by dx is going to be equal to dy by du times du by dx, right? So in order to solve this, we first have to differentiate what is the outer function and multiply it by the derivative of the inner function. So if y is equal to f of x is a function of x, but x is a function of u, then the first order derivative can be derived as follows. So this is the process that you will follow. Let's look at the following example. Here we have y is equal to f of x, which is equal to, in brackets, we have 4x cubed plus 7. So this is the inner function, and this is raised to the power of 5. So if you think mathematically, what would you ordinarily do? You would do what is in the brackets first, and then raise it to 5. So the power of 5. So you have an inner function and an outer function. So we're going to let our inner function, that equal to u. Thus, we can rewrite it as y is equal to u. This portion over here, we let it equal to u raised to the power of 5. Let us differentiate our outer function first. So we have dy by du, and that is going to be equal to 5u to the power of 4. And how did I get that? Well, dy by du, 5 multiplied by the coefficient in front of the u is 1, so that would be 5. And that then becomes u raised to the power of 5 minus 1, which would be 4. And then our inner function over here, this portion, if we differentiate that, we would get du by dx, and that is going to give us 3 times 4 is 12, and this is going to be x raised to the power of 3 minus 1 is 2, so it's 12x squared, and this constant differentiates to 0. Now we can multiply the derivative of our outer function with that of the derivative of the inner function. Thus, f dash of x gives us, we can multiply these two, and we can substitute what we have for u in over here. So we have 5 in brackets what we had for u raised to the power of 4 multiplied by the derivative of our inner function again. Thus, we have 5 times 12x squared. That's going to give us 60x squared. And in brackets, multiplied by 4x cubed plus 7 raised to the power of 4.